So what's the universe? The universe has 50 conscious agents networked together somehow, one of which happens to be me.
What do you think of conscious agent theory? And maybe give a little primer on how you think about it. Is there a way to think about conscious agent theory in simple terms?
Well, I actually worked with Don and Robert in that area some time ago. We published a couple of papers in that area. And I am not completely familiar with what Don or Chetan or Robert have done recently in that area. I've seen some of their papers, but have not looked at it in enough detail to understand completely the assumptions they're making. But I would say that okay, I'll put it this way. One can think of taking a couple of different approaches when one thinks about interacting agents. One approach is to start by modeling the agents and assemble the agents that you modeled into a network and see what happens. And that was the original idea of conscious agent theory, that we're going to start with very simple agents. And Don was actually very fond of talking about 1-bit agents that could only process 1 bit at a time. And connecting them together and see what sorts of larger scale behavior might emerge. So that's one way that one can proceed.
What really is an agent? Sorry, before you, just because I think it's not quite clear to me what an agent actually is in this circumstance.
Oh, well, in the formal theory, at least as it was laid out when I was quite familiar with it, an agent is really just a set of Markovian kernels. So it's basically a set of processes. There's a perception process, a decision process, and an action process. And so you can think of an agent coupled to an environment as a little loop, right? Information flows into the agent, it gets processed somehow or other, and then it flows out back into the environment, where the environment processes it somehow or another and sends some of it back to the agent. So an agent is just something that decides what to do with some incoming information and does something. That's it.
So it really is an information for to loop back in everything that we've talked about information. This conscious agent theory would be an example of a very information based theory. It is foundationally about information.
Yeah.
Yeah.
So when so we can start with constructing very simple agents and connecting them together in networks. Another way to start, which is the way that my recent work has gone now for several years, is to start with some idea of a universe that has some property. And in quantum theory, the key property that the universe has is that information is conserved. That's called unitarity. And that's kind of the first axiom of quantum theory, is that information is conserved. So you start with this thing of some size or other. So assume that it's a big thing and cut it in two somewhere to define a boundary. And then say, okay, what does the interaction at this boundary look like? What kind of information is flowing back and forth between the two halves of this universe at this boundary? And how do we describe what the systems are doing with that information? And the tools that one naturally builds in physics are, at least from my perspective, a bit more conducive to working in that latter way. Um, because you can assume that you have as much bandwidth as you need to construct some structure. So, for example, let's go back to space-time, right? If I'm going to experience time, I have to have a clock. I have to be a clock. I have to have a memory. And um, if all I can do is process one bit, I can't have a memory. So if you want to talk about memory, you've got to talk about something that's got enough internal degrees of freedom and structure to build a memory. And if I want to experience space, then I have to have some objects that I identify as having identity over time and that have some characteristic that I can measure that's not spatial, as we were talking about. So they have to be clocks, so they have to be something that I can distinguish. So I have to have enough degrees of freedom and enough computational power to represent those things and represent their relationships. So I suddenly have to talk about kind of a big thing and have the formal tools for talking about this kind of big thing. And we haven't even mentioned things like metabolism, right? How do you collect enough energy from the environment to keep yourself running? So, okay, you got to assume a bunch of structure to do that too. So, so um, you end up needing to assume kind of a highly structured system with components that are coupled together in fairly complex ways. And um, I'm sure that's possible in conscious agent theory, right? Because you're just dealing with Markovian processes, and you can put those together any way you want to make a bigger Markovian process. So, uh, so it becomes more of the choice between, if you will, bottom up ways of thinking and top down ways of thinking. And I tend to be kind of a top down person.
Interesting. My understanding of conscious agent theory is that there wasn't really an observer independent out there reality, and that the universe was built up from the interactions of these conscious agents. So, so that there wasn't even, I don't know if it's right to say there isn't an environment at the starting point, but what is created the universe is purely the interaction of conscious agents. Now, I don't really know what that sentence means, but that's kind of what I left my conversation with Robert at. Is that sort of a different idea to what you've been talking about?
Uh, no, I think one can make the translation there very simply, right? If you're conscious agent number 23, then your environment is all the rest of them. Numbers 1 through 50, except for you. So, so your environment is now, 49 conscious agents networked together somehow or other. You don't know how. All you can do is poke that environment and see what you can learn from it. So what's the universe? The universe is 50 conscious agents networked together somehow, one of which happens to be me. Um, so that's not a picture that's all that different from the sort of picture that one has in even in classical physics, but certainly not any different from the picture one has in quantum theory. In the quantum theory, there's a whole bunch of degrees of freedom that have different states, and some of those degrees of freedom when they're in particular states are me. And my environment's all the rest in whatever states they are. And the universe is just all of us, including me, plus all that other stuff out there. Um, so I think one always gets back to that sort of picture where you're focused on some system that's interacting with some other system that's its environment. And your job is to come up with some sort of representation of those systems that allows you to say something interesting.
And your central claim is that the best way to understand that system is the information exchange that is encoded in the boundary.
Well, the way to understand what each of the systems can learn about the other system is to talk about the information that's encoded on the boundary. I mean,
Right.
you,
Important to see.
there are always three perspectives here. We as theorists say, okay, I'm going to describe a universe that has these components, and these components interact in this way. And so that's my theoretical perspective. And that's purely stipulative, right? I make some assumptions. I deduce some things from the assumptions. I do some math, and that's it. I do know. I'm not observing the system. I'm saying, let's imagine that this thing exists, or stipulate that this thing exists. But then there are two other points of view in the theory, right? There's the point of view of a piece of that system, and there's the point of view of all the rest. So you can ask, what's the point of view of piece A of the system? What can it tell about the other piece? Piece B, or piece not A, as I like to put it. And the answer to that is the information it can access about not A is whatever not A writes on its boundary.
Right.
So
That's an important distinction.
yeah, it's impossible in a sense to get away from this issue of information encoded on boundaries, because as soon as you divide up your space into systems and define their interactions, then their interaction is defined at some boundary or other, and their interaction that you've just written down determines what each can know about the others.
The Giant Shoulder mission is to explore radical ideas in biology, neuroscience, and consciousness, and elevate those stories to the highest possible level while keeping them accessible to everyone. If this interests you and you want to support independent science, then please consider subscribing to the Clips channel